Okay, so let us go into some details on Cloud Endpoints. You probably remember this picture from lesson 2 where generally we have introduced Cloud Endpoint and we described its capabilities to create one API that you can use to create a client application for many different devices. Well, you may wonder now why these Cloud Endpoints are different from pure HTTP protocol. For example, a REST API. Well, let's look at that. When you are using your Cloud Endpoint, it looks the development environment to inspect and be aware of your API applications. So this has multiple values. First of all, the application design. While designing your backend applications, you can focus on the high-level application design and you don't need to think about your low-level communication syntax and semantics. Cloud Endpoints also performs the native client library generation for a number of different languages. This helps out greatly with a number of different things. For example, communication and establishing a connectivity and error management so that you don't have to deal with any low-level communication errors. But also higher level functions such as your user authentication that we use for your conference center or any of the application. And also since your application API can be expected, Google can provide many tools around it. Your API Explorer is just one example of your such tool, which is extremely useful. So Cloud Endpoint is a great way to develop your APIs that are rock solid, easy to use, portable across device and languages, and can be used with the tools such as your API Explorer. So great value here, in other words, since it lets you focus on your application and let Google take care of all your low-level details. So let us now have a look on your Google endpoints in your development environment. So already we have talked about your task queues into our previous video. So here let us talk about with your start push queue, which is the most common one. So the execution of this push queue are managed by your AppEngine itself. So this means that the application engine has a worker threads that can scan these queues and pick up your task. These threads can call a URL that you have specified when you insert the task in the queue itself. So this means that your execution is broken out from the HTTP request response flow since your application provides your threads to execute the task. But if you talk about the code used to process, each task is still provided by you. Since you provide this URL that worker thread call, that workers will also call the code. So the work with your code that you write. So your worker thread picks up the task by the task and calls your URL for each time of them. So, and this behavior continues for all the tasks in the queue until the queue is completely empty. So by default, the maximum execution duration for the task is 10 minutes. And it is of course up to you when you develop the application to split up the works into the tasks that you create or you have completed within this time. For example, if we have 100 mails each and there are many different configuration options for queues in the following screen. So we will take some of them. First to note this, there are queues for find a queue configuration file when you do development. So all the queues have a unique name. For all applications, AppEngine Order provides a default queue with the name default options, in which case you need to define it in a file. The other thing you can configure are the performance parameters such as the rate of processing, the maximum rate in case of traffic peaks, the bucket size, and the maximum number of concurrent tasks that can be executed. So there are also a lot of parameters surrounding your error management. So as we have talked about defining a queue, so we'll see how we can define this queue. So let us finish this part by looking at how to create a task and assign it into a queue for execution. The very first thing you need to do is to get a queue by a queue name that you create the task and set options such as your task name, URL to process the task, other parameters such as performance, retry options, and finally you add the task to the queue for execution. Finally, it is important that you protect the URL so only administrator can access them through your permission settings you have provided. So you don't want the external users to be able to execute your task logics and should they get the whole to this URL. That was a lot of theory, but this is of now we are going to see how we are going to use this particular task. So before you start creating a task, very first what we need to do is we are going to start with your creating a queue. So for creating a queue, you need to create a file called as queue.xml to create your queues. So to process a task, you must add it into push queue, and Application Engine provides a default push queue named default, which is configured and ready to use when you use your default settings. If you want, you can just add your task to the default queue without having to create any configuration or other particular queues. If you need additional queues or you want to change the default queue configuration, you can do so into your queue.xml file for your application, which you can generally upload on your application engine. And note that you cannot create a queue dynamic into your program. So you can create up to 10 queues for your free applications and up to 100 queues for your billing enabled applications. Now here you can see this is the queue.xml file which generally we have. Here you can see there are queues which are mentioned here. There is a queue with name queue blue, and we have defined the target v2 task module. Same way we have a red queue, and we have also defined the rate of it, that is 1 per second. So this is the queue which we have created. So all the tasks added to the queue, that is your queue blue, are sent to the target module v2.task module. The refresh rate of your queue red is changed from 5 per second to 1 per second. So the task will be dequeued and sent to their targets at the rate of 1 task per second. So there are many other parameters that you can add to your queue.xml file to customize the behavior of your push queue. So for getting more details of your push queue and their parameters, you can find the push queue.xml file and their references, so that you can get more amount of data, what exactly the parameters generally you can use it to. Now how we are going to define this push queue processing rate. So as we said, like there are a number of parameters. We can use the rate, we can use the bucket size, we can use the maximum concurrent request for this particular queue. So you can see this is an example where generally we have used some of the parameter for a particular queue. Now you can see we have already defined the rate into our previous screen as well. Now here you can see we have also defined the bucket size, and also we have defined the maximum concurrent request. So it will be a 10 request you can provide. Same way you can define the storage limit for this queues. So you can see here we have defined the total storage limit, that is 120 MB. That is a total storage limit for this particular queue which we have created. So you can also define some limitations, so that what is the storage amount of the storage the task can consume over all the queues. So you can define for each queue, or you can define the complete storage for all the queues which you have created. So the value in the number which is followed by your B, that is called as a bytes, or we can use K for kilobytes, we can use M for megabytes. So here we have defined M. Same way you can define G for gigabyte, T for terabytes. Now for example, you have 100K specifies a limit of 100 kilobytes. If adding a task, you would cause the queue to exceed its storage limit. So the call which generally you add to this task will again fail. So the default limit is 500 megabytes for your free applications. For billing application, generally you have no limit until you explicitly set one. So you can use this limit to protect your application from the fog bomb programming errors, in which each task adds multiple other tasks during this execution. So if your application receives error from insufficient storage quota when adding a task, increasing the total storage limit can help you for it. So if you are using the feature, we strongly recommend that setting a limit that corresponds to the storage requirement for several days worth of tasks. So in this way, you can create your application is robust, your queues being temporarily backed up, and can continue to accept new tasks while working through the backlog, or we can say backlog, which still begin protect from your fog bomb programming errors. So this is what exactly we have seen about how we can create your task and how we can define this task into your queues, and we can define the push queues and your task. So here we have created a task. We have seen how we can create a task. Now what if I want to push this queue tab list all to the queues in the application? Now you can create your task queue details page where you can see all the tasks in selected queues. So already we have discussed about your push queues. Now here we are going to look how we can use your pull queues in Java. So already we know pull queues allow you to design your own system to consume your application engine tasks. The task consumer releases a specific number of tasks for your each specific duration, then processes and delete them before the lease ends. So using this queue require your application to handle some functions that are automated into your push queues, what we have already seen. Like your application need to scale the number of workers based on the process volume. If your application does not have handle scaling, you risk wasting your computing resources. If other than that you have no task to process, you also risk your latency if you have too many tasks to be processed. So your application also needs to explicitly delete your task after processing it. So in push queues, your application deletes the task for you. For your application does not delete the push task, after processing another workers might reprocess the task. This wastes the computing resources and risk errors if tasks are not independent. So pull queue requires a specific configuration into your queue.xml file. So already we have used this queue.xml file while defining your push queue applications. Now here we are going to see how we can use this pull queue. Before we move ahead with configuring your pull queue, so we should know some of the parameters, we should know some of the concept of your pull queue. So your pull queue generally, as we know, it allows the task consumers to process tasks outside your application engine and default task processing system. So if your task consumers is a part of your AppEngine application, you can manipulate tasks using your simple API calls from your com.google.appengine API task queues packet, or the task consumer can outside of your application engine can pull the task by using the task queue REST API. So the process works like this. The task consumer releases a task either via your task queue API or the task queue REST API. Then the application engine sends the task data to the consumer, and the consumer processes the task. If the task fails to execute before the lease expires, the consumer can lease it again. After your task executes successfully, the task consumer must delete it. And then the task consumer is responsible for scaling instances based on the processing volume. So here we are going to see how generally it works. So how you're going to pull the task within your application engine. So for pulling the task, you can use your pull queues within the application engine environment using a simple API call to add your task to pull the application queue, lease them and delete them after processing it. So for defining your pull queue, you can specify any named queue as pull queue by adding module pull directly to the queue XML file which we have seen. So here you can see I have defined a queue, and here we have defined the name pull queue, and then more we have defined as a pull mode. If you're using this task queue REST API, you can also need to create an access control list. But generally we need to specify the permission for a user to get access to it. So while if you're using your REST API, you need to define the permission in such a way. Like you can see here, I have defined the queue entries and then name of a queue, module of a queue, and ACL parameter we need to define. This directive will provide you to define your user email address, your writer email address, and your writer email. So here we can define the number of email addresses for your user and your writer email, which will again pull your queue with two users in the ACL, that is your bar@bar.com. Now next what we need to do, we need to add the task to it. So how we are going to add the task, how we are going to pull this particular task, that we are going to see in the next video. So keep watching and get upgraded. So here we are going to talk about your task queues into your Google platform. So your task queues are generally defined as a mechanism where generally we distribute a sequence of tasks among parallel threads for execution. So this global problem is generally broken down, or we can say these packets are broken down into multiple tasks, and the tasks are enqueued into a queue so that it should be resolved one by one. So the task queues API is generally what it does, it lets your application perform your work, and this kind of works are again called as tasks, and it's asynchronously, it shares the task outside of your user request. If an application generally needs your execution work in the background, it adds your task to the task queues. So the tasks are executed later by scaling your AppEngine worker services in your application. So here generally we have two different kind of queues that are called as your push queues and pull queues, which is helpful for you to perform your tasks which are maintained in a queue, and how it performs the task that we are going to see here. So again, as I said, the task queues come into two different flavors, pull and push. The manner in which the task queue service dispatches the task and request to worker service is different for the different queues. Like you have a push queues. So push queues, what it does, it dispatches your request at the reliable steady rate. They guarantee your reliable task execution because you can control the rate at which your tasks are sent from the queue. So you can control the worker scaling behavior and hence your cost as well. And because your tasks are executed as AppEngine request here, so the targeted service, what we have over here, that will subject to your stringent deadlines. So the task handled by automatic scaling service must finish it in 10 minutes so that the other task can again perform and the other queues can be executed. So the task handled by the basics and your manual scaling services can run up to your 24 hours. But generally we have a pull queue. So the pull queue, it do not dispatch your task at all. They generally depend on the worker services to lease the task from the queue on their own initiative. And pull queues give you more power and flexibility over when and where the tasks are processed. But generally, if you see, they are also required you to do more queue management over here, as when a task is leased, the leasing program declares a deadline. So the task will be either complete or to be deleted by the time deadline arrives. Otherwise, the task queues service will allow it to be leased to another workers. So here, if you compare this service, that is your Google pull queues or the Google task queue services, in Amazon you have SQS, that is called as simple queue services. You might have heard about your SQS, that is simple queue services, into your Amazon. So what it does, it defines a queue and it becomes a central repository for unprocessed tasks. So then you create a set of worker process on like your any process generally we have over there, like EC2, like virtual machine generally, which we have here, that regularly polls the queues to see if there are any available tasks for processing. If the worker process finds an available task, then the task becomes locked and allow the workers to process it without other workers having access to it. So once the work is complete, it removes the task from the SQS. While this approach generally provides a lot of flexibility, it requires a constant running workers process that are polling for available works. In addition, if there is any spike or task in the queue, you must also manage the scale up and eventually scale down for your workers. Same way, in contrast for this mechanism, your GAE, that is your Google App Engine, it provides a push model. So instead of having an arbitrary number of work process constantly polling for available tasks, GAE generally what it does is instead it pushes the works to the workers when the tasks are available. So this work is then processed by the existing auto-scaling GAE infrastructure, allowing you not to worry about the scale up and the scale down workers. You can simply define the maximum rates of processing and your GAE take care of farming out the task to the workers appropriately. So this is about your task workers, and we have seen we have two types of task workers here. So we are going to see how we are going to arrange these queues, how we are going to configure this task queues into our GAE. So keep watching. In the next video, we are coming up with the configuration part, so upgrade yourself to it. Now here we are going to talk about scheduling tasks with Cron for your Java. So as we know, this AppEngine Cron service allows you to configure your regular scheduled task that operates at a defined time or regular intervals. These tasks are commonly known as the Cronjobs, and these Cronjobs are automatically triggered by the application Cron services. For instance, you might use a cron job to send out an email reports on a daily basis, or to update some cache data every 10 minutes, or refresh summary information once an hour. A cron job involves a URL using your HTTP GET request at any time of the day. The cron job request is subject to the same limits as those we have to push task queues. So how you can recreate your cron job? So create a cron.xml file in the web.inf directory, add one or more cron entries into a file, and define the necessary elements for your job, including the required URL and the schedule elements. For example, you can see here I have created a cron.xml file where generally I have defined a cron entries, where I have created a cron URL with a task summary, and have defined a target as a beta and description as daily summary job, and it is scheduled after every 24 hours. And I have closed this particular cron element. Now the target specification is optional and is the name of the service or version. If present, the target is pretended to your application host name, causing the job to be routed to the service or version. If no target is specified, the job will run in the version of the default service that are configured for the traffic. You can create the handler for this Cronjobs URL. The handler should execute any task that you want to schedule. The handler should respond with the HTTP status code between 200 to 299. The other status code can be returned and can be used for triggering the retry these jobs. Same way, the testing cron jobs is the development server. How we are going to do it, that we are going to see here. Now once you have done with it, as we know, the local development server, that is Dev app server, doesn't automatically run your cron jobs. You can make a request directly to your cron job URL to test your functionality. You can use your local cron or your schedule task interface to trigger the URL of your jobs with a curl or similar tools. So how you are going to upload this cron jobs? So for uploading this cron jobs, you can use application cfg.ch tool to upload your cron jobs to your application engine. Upload your whole application by using an entries from your cron.xml file, where we are going to run a command .AppEngine Java SDK and a bin appcfg.sh file. So this is a location from where I'm going to update your application, and you can update your application directory here. Then you can upload only your cron updates by using the same command, but the command will be changed to your update cron, where in previous we have defined the command as update. So the update will update the complete application, while the update cron will update only your cron jobs. Now if I want to delete any cron jobs, how I'm going to do that? For deleting the cron jobs, you can edit the content of your cron.xml file to only this one. So you need to completely remove the cron entries and the cron elements. And then you can again upload your cron.xml file to your app engine by using your update cron. Same way, if you have scheduled a cron job and it's failing, how you can retry the cron job if it is filled? So if your cron job request has handler, returns, and status code that is not in range of 200 to 299, your app engine considers the job to have failed. So by default, the jobs are not retried. So if you want to retry it, you need to include a retry parameters blocks in your cron.xml file. So for that, you need to choose and set retry parameters into retry parameters block. For example, you can see here, I have defined a URL. Into that, I have defined a retry. And this particular retry will be started after 2.5 seconds of the first task when executed. So every time, it will double each time. You can see here it is 2.5, then it is doubling to. Same way, once you have set this retry parameters, you can again update it by using your update cron command. Same way, you can secure your cron by using a securing your URL. You can prevent users from accessing your URL caused or used by your scheduled task by restricting access to your administrator account. So as an example, you would see in web.xml file to restrict everything starting with your cron to admin only. So here you can see here I have defined the security constraints, where a web resource collection I have defined and the web resource name is your cron, while the URL pattern I am using, that is anything starting with your cron. Next, web resource collection, again I have ended here. Then authentication screen, I have defined it for your admin. So I have defined a role with name admin, where generally I will be defining the complete access role to this admin. And we have ended the authentication constraint over here, and the security is ended. So this is how generally we can provide a security to the URL of your Cron so that we restrict access to the administrator account. Same way, we want to test a cron job signing in as an administrator, you can visit a particular site where generally your application is connected, or you can request from the cron service will also contain an HTTP header where we can define x AppEngine cron equals to true. And this AppEngine x AppEngine cron header is an internally by Google App Engine. If your request handler finding this header, it can trust that request in a cron request if the header is present. In an external user request to your application, it is stripped, and except for your request from your logged in administrators of the application who are allowed to set the header for the testing purpose. So you can use your Google App Engine issues cron request from your IP address 0.1.0.1. So here we have seen about your cron services, how we can create your cron services, how we can call these cron services, how we can connect to this cron services, and how it works. And also we have seen how we can delete or flush this cron services from your application. So here we have completed with this particular content.